Thank you. Hello, my name is Shin-Hwan Kim. My company is Korea Telecom KT, South Korea. I am researching and developing in wireless access technology team. The title of my paper is Fast Rank Optimization Scheme by the estimation of vehicular speed and the phase difference in MU-MIMO. Yeah, the table of this contents is as follows. First is I will introduce the definition of MU-MIMO, and the second we will see the mathematical modeling of interference nulling, and the third is I will introduce a rank decision scheme, which is conventional rank decision and the proposed rank decision scheme, and we will compare the pros and cons and the performance. The last, we see the additional test result. MU-MIMO or MU-MIMO.
I'm sorry, Sin, I have to interrupt you. Is it possible for you to turn your video on?
Sorry?
Is it possible for you to turn your video on?
Oh, sorry. My camera is broken.
Okay.
Okay, sorry. Okay. Yeah. So the MU-MIMO is a multi-user, MU-MIMO is multi-user, multiple input and multiple output. MU-MIMO is technology for multipath wireless communication to multiple users by allowing duplicate use of same resource. In contrast, a single user MIMO, that is SU-MIMO, involves a single user without duplicating the same resource. The important feature of MU-MIMO is nulling of inter-user interference for system evaluation, interference nulling. The left is the beam before interference nulling, and the right is the beam after interference nulling. When the base station transmits the blue UE1 beam and the red UE2 beam, like left picture, the power of red side lobe beam of UE2, this is main lobe and this is side lobe, UE2 is transmitted very strongly, like left under picture. So the SNR of the blue main lobe beam of UE1 becomes very small to -2 dB. Similarly, the power of blue side lobe beam of UE1, blue side lobe beam, this is main lobe and this is side lobe. Side lobe beam of UE1 is transmitted very strongly, like left upper picture. So the SNR of red main lobe beam of UE2 is become very small, to 4.8 dB. To eliminate the interference between UE beams, the nulling technology of various methods are introduced the section below. As a result, if the interference canceling method is used, the beam shape as shown on the right figure is derived. When the base station transmits nulling beam of blue UE1 and red UE2, like right picture, the power of red side lobe beam of UE2, this is main lobe and this is side lobe, UE2, is transmitted to UE1 very weakly, like light under picture. So the SNR of blue main lobe beam of UE1 becomes recovery to 24.2 dB. Similarly, the power of blue side lobe beam of UE1, this is side lobe beam, is transmitted to UE2 very weakly, like right upper picture. So the SNR of the red main lobe beam of UE2 becomes recovery to 24.7 dB. This page briefly represents the channel model of MU-MIMO. H1 is a channel matrix of UE1, and H2 is the channel matrix of UE2. And this page represents a block diagram including the channel of MU-MIMO and the mathematical modeling of zero forcing transmitter. Here, the X characteristic label I is an interference signal. Its mathematical model may be represented as shown in equation number 1. And if we represent it as a matrix, each is represented equation 4 and 5. This is matrix and this is result. The H1W2S2 of equation 4, this part is an interference signal which is UE2 beam, like X characters, this path. And H2W1S1 of equation 5 is the interference signal which is UE1 beam. This path. So in order to remove this interference signal, equation 6, this is equation 6. Equation 6, that is the zero forcing beamforming function, is assigned. In order to remove the, as a result, the new weight is multiplied, such as equation 8 and 9, and the interference signal is eliminated. Another interference method is SVD transmitter. SVD transmitter means singular value decomposition. SVD is a method of obtaining pseudo-inverse by decomposition with a singular value. This method is what does precoding in the transmitter by decomposing into singular value sigma and the unitary matrix U and V as shown in the following equation 10, and what does postcoding in the receiver to obtaining identity matrix. Overall, we can overcome the channel pseudo-inverse as shown in the equation 14, right? This is identity matrix. So this page introduces conventional rank decision scheme. The conventional rank decision method is a popular method used by SU-MIMO, single-user MIMO. That is, it is a method of determining rank by estimating the independence of antenna by CSI-RS. This is CSI-RS. CSI-RS means channel state information reference signal. This is reference signal. In order to well represent the characteristic of the MU-MIMO beam, it is necessary to transmit the CSI-RS that represents the interference among UEs where. That is, NGP CSI-RS-CM and NGP CSI-RS-IM. This means non-zero power CSI-RS-CM. CM means channel measurement, and non-zero power CSI-RS-IM. IM means interference measurement. This figure is an example of RE mapping for transmitting non-zero power CSI-RS-CM and IM. RE means a resource element. This is resource element. When transmitting the CSI-RS to the base station as shown by this picture, the UE will perform interference measurement by estimating the level of interference at the empty RE position of the white color. This RE is interference measurement. And UE will determine the rank accordingly. This method of changing the CSI-RS for MU pairing is very slow, so it is not suitable for a mobile environment. Because the MU-MIMO system has a lot of interference, we need to faster change of rank than SU-MIMO system. This page shows field test result at low and high speed respectively. Left figure shows the throughput of rank 3 is better than that of rank 4. Rank 4 in case over 2 kilometer per hour. This axis is vehicular speed, and this axis is the downlink throughput. Also, right figure show the throughput of rank 2. Rank 2 is better than that of rank 3 in case over 200 kilometer per hours. These are fixed rank test result because of before being applied optimized rank scheme. Finally, recent commercial UEs are not good at determining optimal length according to vehicular speed. The first process is the estimation of vehicular speed. The first process is speed estimation by SRS phase difference. So estimation of a vehicular speed by obtaining the difference between beamforming phase value and solving the distance by the path loss estimated by the omnic SRS. SRS means sounding reference signal. It is a kind of reference signal. The procedure is as followed. First process is that derive the distance between the base station and the previous subsequent point with SRS path loss respectively, like A and B. And next process is that derive the received beamforming angle theta by the SRS channel estimation, like theta and pi. And last, calculate the vehicular speed by obtaining the distance by position change per SRS duration. Speed equal distance over time. So speed equal A to B distance, A to B distance over task duration. Task means transmit antenna switching means SRS duration. And the second process is rank decision. The second process is rank decision by the speed. Each commercial test condition of before page was specified in this page table. So if there are no other fading element, we can select the largest value from the range for each speed. If vehicular speed is 0 to 2 kilometers per hour, we can select maximum 4 rank. And if vehicular speed is 2 to 200 kilometers per hour, we can select the maximum rank 3. And if the vehicular speed is over 200 kilometers, we can select the maximum 2 rank. Finally, the proposed scheme is divided into two main parts. So the first process is a vehicular speed estimation, like this page. And the second process is the rank decision process according to range of vehicular speed. The combination of these two methods is not only based on UE dependent scheme, but also based on base station dependent scheme in the rank decision. So this page shows the pros and cons of a conventional scheme and proposed scheme. The pros of conventional scheme is high rank, and cons is slow change of rank. The pros of proposed scheme is fast change of rank, and cons is a complex implementation. This page shows overall performance graph apply the new rank optimization scheme. The performance of low speed UE, has been significantly improved to maybe 16.7% compare this and this. 16.7% compared to a conventional method. This is conventional method and this is optimized rank scheme. And the performance of stationary UE, stationary vehicle, stationary UE performance is similar regardless test condition, similar. Also, we can fixed low rank scheme for reference like this. So we did this test in KT lab in Seoul and the high-speed train. It is a route that start from point A and point B and return at the low speed, respectively. This page is a commercial UE log when the conventional rank decision method is applied. And this page is a commercial UE log when the proposed rank decision method is applied. So the red background is a part of MU mode operation, multi-user mode operation, when two UE are separated from each other. And the blue background is a part of SU mode operation. SU means a single user mode operation when the distance of two U is very close to each other. This mode operation transition is designed to automatically switch to the MU mode and SU mode operation. So if the correlation coefficient is increased, change the SU mode like a blue background. And if the value is decreased, change MU mode like a red background. This page a proposed rank decision scheme is applied. As a result, the throughput of proposed scheme is about 609 megabps, 609 megabps. And the throughput of conventional scheme is like this, a little character. So 515 megabps. So the throughput of proposed scheme is 18% better performance than the conventional scheme, because the rank of a proposed scheme is slower than that of a conventional scheme. Conclusion. The conventional rank decision scheme is very slow rank change, so it is not suitable for mobile environments. The proposed rank decision scheme is fast rank change method. So the first process is a method of estimating and calculating the vehicular speed in order to decide the rank value. And the second process is the rank decision according to the range of vehicular speed. The throughput of proposed scheme is about 18% better performance than the conventional scheme. Thank you.